Hello and welcome back to D3D12Ez, the video series where we're gonna take an ad hoc approach on DirectX 12 programming to basically get something on the screen fast and then also expand on that and learn a bit about rendering. So here we are back. In the last video what we have done is we created ourselves a comment list and we have executed the comment list, and therefore we have created the most basic loop that we can do in DirectX 12. Initialize our debug stuff, initialize our DirectX 12 context, create a comment list, execute the comment list. Now this is the basic framework that we're always gonna have on every DirectX 12 application. And now what we are dealing with is the section in between. And the section in between is a lot of setup and then a draw. And after that draw, actually even after the comment list has been executed, show me the stuff. So this is basically the framework that I have basically now just created for us to explore. So these three parts here, do a lot of setup, do a draw, and show me the stuff. This is what we want to deal with in the next few following videos. Now in today's video we're gonna take a look at a so-called window. Now, in order to display something to the user, so in order to draw something that we can observe, that we can look at with our eye, we need some context where we're going to render to, because DirectX 12 does not come with something like that out of the box. You could use DirectX 12 and just render to some arbitrary memory in the GPU, download the memory to the CPU and store it somewhere on disk. So you can do it. You can do a full rendering without showing something to the user. And this is actually quite nice. I have once written a tool that was actually reprojecting texture coordinates of three-dimensional objects into a two-dimensional space and then use that as a mask to combine textures together, because of a way on how Substance Painter back in the day worked and didn't work for me, and there were multiple tools that tried to solve that in Photoshop and Dedicated, and they didn't really work as well. So I wrote myself something that kind of like did observe the geometry, and I wrote that in DirectX 12. It's up on GitHub if you're interested, and it basically did some rendering without showing something. Now what we need is we need a window. What is a window? Well, that is a window. This window here, Microsoft Visual Studio with the rounded edges, this is a Windows window, and what we want to do is we want to create exactly a window like the Visual Studio window. We want to create that window and we want to use that window to render to, and that's what we want to do today. Now creating a window in Windows isn't as straightforward as you would think it is. Now what we're going to do is we're going to go into our supports directory and we're going to create a new not class, we're going to create a new file here, and what I'm going to call that one is basically just window.h. Now it's important that you don't call this windows.h, because if you're calling it windows.h you're going to have problems. I just going to call it window. I hope this doesn't conflict with any other Microsoft header, but I think it shouldn't. Alright, so now we have the window class, and what I want to do is I basically want to copy my singleton architecture that I've always used, and I'm basically going to copy it from here. And I'm going to paste my singleton architecture in there. Now what I want to do is I want to have an init and a shutdown function. The init and shutdown function shall create one default window, and that's the one and only window that we're always going to have, because we are not going to support having multiple windows. Of course, Windows is designed, the Windows operating system is designed to allow multiple windows. Of course, Visual Studio, if I drag off the Solution Explorer, it comes dedicated. I can move it off screen to a different monitor. This is now its own dedicated window. And if I drag it back in here, it's joined back into the big Visual Studio window. This is something called a dock space, or it has multiple names coming from different kind of like concepts and vendors, but we really don't want to care about that one. We today just care about a very basic DX window. Alright, like that. Now, what does a basic window need? Well, a basic window needs something called a window class, and it needs a window instance. Now Windows works like that. You're always going to have a so-called window class. The window class is going to describe how your window is kind of like from a very basic standpoint of parameters, how it is interacting with the desktop. Should it use the memory of the desktop, or should Windows be allowed to share the memory with the desktop? Should it use its own dedicated memory? How should window creation be handled? How are the so-called window messages, so certain callbacks that are executed, how shall they basically interact with the the application or with the operating system. And this is defined by a window class. And that's the first thing that we want to do. So let me quickly create a file here for that file here. And let's start with the init function. So the first thing that we need on the init function is we need a window class. Now, how do we create a window class? Well, we're going to create a descriptor for that window class, vnd class xw. This is the descriptor that I want to do, vcx for window class x, initialize the memory to 0, and now we are ready to describe the window class. I'm going to do this by stealing all its parameters, by copying them from here into my code base, and now what I want to do, vcx dot, let's remove the lines in between, and then we can go through all of these parameters step by step, and I can explain what they are. Now, the first one is something called a CV size. This should always be the size of VCX or the size of W and D class W. But you should always use this like the variable name, so if this one ever changes like to the class A, it stays the same. Now, the next thing that we need to specify are so-called window class styles. Window class styles are bit flags that specify how the class behaves. These bit flags are stored under the prefix CS for class style. And as you see, if I type in CS and then control space, you can see that we have many informations here available on class styles, how I can specify them. However, we are using DirectX 12, which means that we do not need too many dedicated types here. We don't really care about who vote them too much. We just want to have something called OwnDC. OwnDC stands for own device context, which means that the window has an own window DC, device context, on how to draw in the window. We need it for DirectX 12. Now, the next thing that we can specify is something called a window proc. The window proc, if we are taking a look at that, is actually a function pointer. Now let's dive into and see how it looks. It is a function pointer that looks like that: lresult, callback, window proc, hwnd, un, wparam, lparam. Now, this one is always required. We always need that callback, and what I want to do is I want to, of course, also implement them. So static lresult callback is what we are looking for. Window proc, I'm going to call this one on window message, because the window proc is handling window messages. Then we have an hwnd, this is the window. Then we have a uint, this is the so-called message. We have a wparam, this is also called wparam, and then lparam, that's called lparam. These parameters are basically specifying certain arguments to a certain message. So as soon as something occurs in our window, it is going to tell us which window occurred this message by giving it a hwnd, a window handle, a message, which is a code, what happened on the window, and these parameters depend on what code was sent. I make this one static so that we can basically abuse it in here, and what we then gonna do is we gotta specify the function name here, so function pointer to dx window on window message, like that. And now I have a function pointer to that callback. Now what we want to do in that callback is by default call something called def window proc. This def window proc function is basically the default behavior. So, for example, if the user wants to close the window or presses Alt F4, the default behavior is gonna close the window, obviously, and destroys it, and then the application can terminate. And we want to basically take the default features that we have, and then later on we can add some different code. And basically, what we're later gonna do is we're gonna switch on that message, and if something occurs that is special that we want to handle, then we can go inside of that loop here, or inside that switch, handle it, and then return our own lresult status code. Now, the next two parameters of the struct are the parameters on additional memory. Now, Windows allows you to allocate additional memory per class and per window. We're not going to use that, so we're going to put this one to 0. Now, the next parameter is something called an H instance. A H instance is the instance of the application that is registering the window. You can get this H in the instance by calling the get module handle function and null pointer in it. If you provide null pointer to get module handle, you're going to get the handle of the current active module, which is in this case our executable, and the H instance is going to be the same here because our application, our exe, is going to do it. So getting the module handle with null pointer is fine here. The next thing is an icon that we can provide. We can provide this and set this to null pointer. However, I want to show you how it works. Load icon is what we want to call. Load icon W or whatever. Maybe W, I always use them. We need to provide an H instance from where we want to load the icon. In this case, we're going to provide null pointer and not our modules handle, because if we provide null pointer here, it's kind of like system default or something like that. And then we can specify IDI application, which is the default icon that an application is going to get. Same works for a cursor. So load cursor W. And also null pointer IDC error is the cursor. So IDI stands for ID icon application and ID cursor error. Now we can also specify an HBrush background, and HBrush background is used to redraw the window when it's resized. So it kind of like defines the background color. We want to set this to null pointer since we don't need a background color. It's been drawn by DirectX 12. Then we can specify a menu name, but we don't want to use a menu in this case, so we set it to null pointer. We specify a class name, D3D12Ez, window class. So this is basically a name that references that current descriptor. So later on, if we're creating a window, we can specify this class name, and then everything is fine. Now down here you can see we now have another icon, H icon small. I'm also gonna call load icon here. IDI application. And now if we provide all these parameters, we should be good to go with our window class. Now to also apply this window class, we need to make sure that we register our window class. So register window, no. So register class XW, this is the function that we want to call. We're going to give it a pointer to our VC extract, and what it is going to return us is something called an atom. The atom that's returned is basically a reference for that class that we can also use for creation. So what I can do is I can store this and say something like my window class. Store that atom in here so that we can easily reference. Okay, the atom is an integer, so I set this to 0. So what I'm gonna do is I'm gonna assign this to my window class. Now, of course, I want to validate that. So if window class equals 0, return false, so that I can return out of here. And I like to at least keep my conventions. I can like did this nowadays. Okay, so if this passes, I want to return true because my window class was registered successfully. Now the only thing that's left to do is we need to implement the shutdown method. So if my window class exists, I want to unregister that. Unregister class W is the function, and it takes a class name with an H instance. I'm not quite sure. Let me quickly validate something. Unregister class should, I think, also be able to take a atom. Yeah, so you can see unregister class can have the string or a class atom. The string is would be that string, so I can reference the class by that name. However, what I want to do is I want to provide the atom. This is a bit more straightforward. Of course, you need to cast the atom then, lpcw string. I just want to use the atom because it's a bit more safe to use the atom than the class name. Now get instance, again, get module, handle, null pointer. I mean, yeah, we could now, since we are using the H instance multiple times, store it in the class, but I think get module handle is actually a good call. Just also get module handle W. Alright, so this is basically done for unregistering the class. Let me quickly see if this works. So let's include support window.h. There we go, the window is in here. And now what I want to do is I want to initialize the window as well. So dx window get init. This should also work, and then I'm going to go into my my infinity loop. So let's make a breakpoint here and see if we are going to go into the infinity loop so that everything has been initialized. And there we go, we are inside of the loop, so our initialization was successfully. We have registered a window, that's good. So now, or window class, sorry. So we have now successfully registered a window class. Now it's time for creating a window from that window class. So now I want to have a window. Now, how do I create a window? Well, it's very simple. Create window xw is the function that we want to call. This function is going to create ourselves a window. Now, the first parameter is something called a x style. Now, an X style is a so-called window extended style. It's similar to the style of the window class. It is basically specifying how our window shall look like, or what the classes, the parameters of our window are. So VS are the attributes, and there's also something called VSX. And or it's VS underscore X, and VS underscore X are the extended window styles that are available. Now, what we want to do is we want to create something called an overlapped window. An overlapped window is a default Windows window, and what we want to do is we want to take that overlapped window and we want to add another parameter to that. The parameter called app window. App window just makes sure that this window is like always first choice when having multiple windows. Yeah, I'm currently not supporting multiple windows, but I tend to always put it in here. Now, the next thing that we need to do is we need to specify a class name. Again, we're going to use our Adam lpcw string, cast it to that. That's good. Then we need to supply a name for the window. The name for the window is kind of like what's inside of the title bar. So the name of this window here is D3D12Ez. I'm not quite sure if it's really D3DEs because it's Visual Studio that's rendering something else. No, the name of that window is D3D12Ez Microsoft Visual Studio. That's the name of the Visual Studio window, for example. And I want to provide D3D12Ez. Well, the next thing is the normal style attributes, and there as well we want to have overlapped window. If we are going to use the X styles for overlapped window, we're going to use the overlapped window for the normal styles as well. And to make the window visible, I'm going to give it the style VS visible. We can also toggle the style later, but you can just plainly give it the style visible and the window is going to start as a visible window. Now, the next thing that we need to provide are positional parameters, X, Y, width, and height. I tend to always provide 100 and 100 for X and Y, then for width 1020 and for height 1080. So I tend to create my windows on like a HD resolution. Then we need a parent window. We can put this to null pointer, which basically means no parent window. We can provide a menu. We don't want to provide one. We are going to provide an H instance. I'm gonna steal this from the window class. It's not 100% clean to do this, but yeah. Now the last parameter is a lp void lparam. The lp void lparam is a user-defined parameter that you can pass with your window. We are not doing this here object-orientated, so we are not going to needing this. If you want to do object orientation with Windows, you can use that and abuse a trick to make that C-style API look like your class method on window message is called. Alright, so this is a rather long line of code, but it's ready, and what it says returning is a so-called HWND, so this is the kind of like window handle, and we want to of course also store this, HWND m window. Now, by default, this handle is going to be null pointer. Now, what I'm going to do here is I'm going to assign it, and there we go. Now I want to do a quick check, return not equal nulls, or null pointer. So if it has been created successfully, everything is good, we can continue on. Alright, so this creates a window and we can already check this out if it works. So first of all, if the breakpoint has been hit, everything is good. And what I can already see, you can't see that if I switch the screens quickly, you can actually see that we have a window here. You can see that white window here, and my OBS window window has currently been created. The problem is it's on the wrong display because of the wrong monitor, because my primary monitor is not the one that I'm recording currently. This is not an issue. You can easily fix that. However, we're going to do it in a second. One thing that I want to show you is that our window is not operational. I'm not able to open the window. I'm not able with like shortkeys to get it on a different screen. I can't currently interact with that window. I can't even close it, right? If I click on close here, you can see it's not doing anything. It should close by default behavior, but it's not doing it. Why is it not closing? Well, the problem is that we are not polling the window. Every window needs to be served, so we actually need to write a function that serves the window every frame. Now, how can we write such a function? Well, we're going to write it, of course, in here. So what I want to do is I want to write a void update. The void update shall update the window's current state. So we have now init, maybe let's move it up, init, update, and shutdown. And let's quickly implement the method here, and there we go. Now, how do we update a window? Well, we basically need to call the window proc, more or less. And we are doing this by basically asking Windows, the operating system, if our window has a message, a so-called event, message, however, it's called the on-window message. It's a message proc. It's kind of like a message on that window. And if we have that message, we need to modify that message and dispatch it. So first of all, we need a message struct. We need to be able to kind of like get the message. Now, the next thing that I want to do is I want to peek if a message is available. Peek message. So we want to peek. We can peek with the peek message function, peek message W. Now the peek message function takes a pointer to a message. Then it takes a window handle. It has a filter min and filter max. You should always put these to 0. And it has a parameter remove message. Now peek message can operate in multiple ways. Now peek message, if I would provide false or no remove in here. If I would put PM no remove in here, we would get a copy of that message, but the message is never going to be removed from the event queue. We don't want to do that. We actually want to remove the message by calling or putting as an argument PM remove in here. And by putting PM remove here, we basically copy the message to MSG, and then we're going to remove it from the event queue. And what we want to do every frame is while this function succeeds, so as long as we have messages for that window, put them into the message buffer, enter the while loop. What are we going to do in that while loop? We're going to translate the message. Translating the message is required to whatever, translate parameters around. I don't really know why, but you need to basically translate that message to a certain format, and then you need to dispatch the message. Now, dispatching the message is more or less basically just going to call your window proc. It's doing a bit more. It's going to go in and check the operating system, which on the WinRP checks if the message proc is set, which message proc is set, and then it dispatches that. So it does a few things, but basically it is just calling the right on-window message function in here. So this is the line that we need, the lines of code that we need to update our window every frame. Now we just need to call it. Well, when do we call it? I would call it before the comment list. So dx window get update. That's what we want to call here. And as soon as we are updating our window, it should be becoming responsible. And now, yeah, as you can see, I'm able to drag that window on that monitor. You can see the title. You can click it, move, size, minimize. It works. Open this up. As you can see, if I open this up, it is now black. This is because it's not going to have a default brush. And what we're going to do, of course, as well, is we can resize it. And you can see that it's not really doing what it should do, but that's okay. We do not do WinAPI drawing. If we would have a default background brush in the window class, it would do it, but we don't have it. So we are basically getting some odd patterns here that are basically being drawn by the border here inside of the buffer of the window. And if we are increasing the size, the border is basically inside now our drawable area. But this is basically the area that we later on want to serve with DirectX 12. Now, one thing that you're going to observe, if I close the window, nothing happens. Now, why is it a problem? Well, because closing the window is basically closing the window. It's doing nothing more. The window still gets updates, the window still lives, it's no longer visible, but it is there. What we need to do is we need to handle manual window destruction. How do we do it? Of course, in the shutdown method. So if the window is existing, we want to call something called destroy window. Destroy. I don't know why my visual assist is today a bit buggy. More actually the last few days, as you can see here as well. So destroy window is what we want to call, and this shall destroy the window when our application terminates. Problem, application still not terminating, because we are not kind of like knowing when the window is closed, because the window is currently it's closed, but we did not get the notify event. So how can we help that, and how can we get the notify? Well, we're going to use the on-window message callback. So what we can do here in our switch is we can check if our message is the WM window message close. WM close is the window message sent when the window is closed. And what we then want to do is we want to return 0, which basically indicates we handle window closing. And if I handle window closing and do it like that, you're going to see that the window now is no longer closable. I can click the button, it's not going to close. I can press Alt F4, it's not going to close. It's never going to close because we basically told the Win API, hey, we got this event, we're going to do it. And now we just need a way to kind of like tell our main file that this button was clicked. And how can we do that? Well, just a basic Boolean flag. Bool m should close. By default, it shall not close. So when do I want to set should close? I'm going to set should close when we get that event. Now we just need a way to poll this. Of course, it's not going to work. We need to first get the instance and then should close because this one is static. But get m should close equals true. Now we have set it that flag. And now we just need to kind of like handle that from within the main. For that, we need to make it accessible. Inline bool should close. Can be const. I know we don't need const correctness here, but yeah. And I'm just going to plainly return m should close. Now I just need to catch it in here. So while dx window get should close, inverted of course. So while it should not get closed, do that loop and then do the shutdown. We need to do the shutdown here as well. We didn't call that one. Not the dx context, dx window get shutdown. All right, so now we have the shutdown in here as well. And now we should regularly open up a window, have it as responsible, and as soon as I click the X button, it shall close. So here's our window. I press the X button, our application terminates. Good, good, good. That's exactly what we want. Now, one thing that I want to quickly solve is I want to solve that the window always starts on the wrong monitor. This is something that you don't really need to have. I'm just going to do it so that you have a bit more joy of doing it. Now, how can I do that? Well, what I want to do is I want to first get where my current mouse cursor is. So basically, I want to start my window where my mouse is. So the function is called getCursorPosition. It's returning something called a point. So I'm going to call this point pos. I'm going to provide 0 and 0 as an initialization value for x and y. And then I'm going to get the cursor's position. This basically gives me where my cursor is currently located. Now what I want to do is I want to determine which monitor this is. So monitor from point should be the function. There it is, monitor from point. I can provide my position and I can provide a flag. Monitor default primary is what I want to do. So in case position is out of scope, we're going to get our primary monitor. And this is an H monitor, so a handle to a monitor. And what I can do with that handle is I can get monitor for info, so I can get the monitor's information. So put in the monitor in here, and then the LPMI, which is a monitor infrastructure. Monitor info. Monitor info. Monitor info. I think monitor info might have a CB size that we need to set. The size of monitor info, and you can see that in monitor info we have something called an RC monitor and the RC work. This is like the working rectangle and the monitor rectangle. And what I can do is when this function succeeds, or not even if it doesn't succeed, because if it doesn't succeed it's zeroed out. Instead of directly going to 100, I'm going to go to monitor info.rcwork.left for the X position, which is kind of like the left coordinate of my monitor. Maybe we should now make this a bit more ordered here, so that's looking a bit better. Ordered here. There we go. Okay. And the same thing goes for the Y position as well, but it's not the left, it's the so-called top. So there we go. Now what I have done is I should have positioned the monitor in the window where I'm currently at, and there you go. Now it is directly opening up here. I can close it, I can open it. If I quickly move my monitor to the other, or my mouse to the other monitor, it of course opens on a different monitor. It's just some luxury for me to not drag around the monitor at the window during the tutorial. place window on current screen. There we go. Now, all these handles doesn't need clean up. The only handle is that one here, but the H monitor is actually constant, that handle, because they are getting initialized by Windows, whatever, so we don't need to clean them up, actually. All right, so these 84 lines of code are basically our construction and base for what's coming up next. Because in the next video, what we want to do is we want to bind DirectX 12 to that window and maybe already start serving the window. All right, so thank you for watching. See you in the next video. Make sure to like and subscribe, and have a nice day. Bye.